The objective of today is to explain the importance of subnetting. And this was a really difficult concept for me to wrap my head around at first. It took me weeks, in fact, because I was really trying to internalize the why of subnetting. I figured the internet would work just fine if, when I'm looking for an IP address, I just ask if a computer has that IP address, and if it's not it, move on. But when you think of the scale of the internet, you could see pretty quickly the importance of having a subnet. So eventually I figured it out, and now I'm here to try to make this concept easier for you to understand, because it's not really as difficult as I probably made it myself. But I sure learned a lot along the way, and so it was still totally worth my time. Now, before we dive in, there's a lot of things you should know before watching this video. Some things include knowing what an IP address looks like, knowing that these addresses are unique or supposed to be unique, that ultimately these addresses can be broken down into 32 binary bits. We call this separation of those 32 bits octets, and so in every single octet is 8 bits each. So you see 4 times 8 is 32 there. This word octet is not to be confused with the octal number system, which programmers used to use a lot more. I guess for certain languages it was a good thing to use, but apparently we just don't need that anymore nowadays, that 3-bit representation of a single octal digit. But I'll never forget this joke. Why do computer scientists mix Halloween and Christmas up? Well, because October 31st equals December 25th. So the octal number 31 is the same as the decimal number 25. So don't forget extra credit if you laugh at my jokes in class. So here's our roadmap. First, I want you to get a grasp of CEDAR notation. When you see this, you are seeing subnetting. The second thing we'll do is learn to read an IP address versus a subnet mask. So as soon as you see these two, you'll know how they relate to each other. Then I'll just spend the majority of the time going over reasons to subnet. And after that, we're just going to practice a bunch. That way, you'll walk away with a pretty good skill from this lesson, not just the knowledge of why subnetting is so important. So as you start this lesson, you should not forget who you are in this lesson. You're not a student, you're not a homeowner with children in your house with different devices and you need to control those devices. No, you're going to be a system administrator. Your job is to help a company get a range of IP addresses. Okay, you're going to subnet these. That way there's different networks for the company to utilize. And so that's the mindset you need to be in. So like you're like this girl or guy here walking down hallways that look like this. Well, if you're walking down a hallway this fancy, you might be working for one of the big FANG companies, Facebook, Amazon, Netflix, or Google, in which case you're working on core routers. For my example, I'm going to try to scale it back though and say you're more like a small business owner and you're working with edge routers. And chances are, no matter whether you work for the big guys or the smaller guys, you're not spending too much time walking around. You're spending a lot of time sitting at your computer looking at a screen that looks something like this. Okay, so let's get you to make an inference before we start the lesson. Here on the left-hand side, we have what's called the subnet mask. In the middle is the binary representation of this subnet mask. And then to the right is the CEDAR representation of that. So using just this picture, what do you think CEDAR is? So to give you a little hint here, if we go down here and we see an IP address like this one, 192.168.10.0/8, that /8 is the CEDAR notation, the subnetting signal that this IP address has been subnetted, has been broken down into a couple networks. And that's all the hints I want to give you as to what CEDAR means for the time being. So have fun with that. Think, right, share. Go ahead and pause here and write down your answer. Now when you come back, let's just review real quick what people are doing when they go on the internet, okay? So they type in the website they want to go to, and what that does is sends out this signal of a IP address. Well, okay, it goes to the DNS server first, and then that server is going to tell you what IP address you need. So now you're flying down the wires, you're looking for a particular IP address, and typically the server you're looking for is owned by either an ISP or companies like Google and Facebook. So we got to find that server amongst very many, and they all sit in these data centers, okay? So in order to get a particular server, you need to travel through the internet. You'll see how this subnet mask plays a role in that in a second. But just what did I just say a server is? You need to know what that is, because that's the whole point of subnetting, is so we could find these things faster. So you're a packet, you're traveling through the internet, you have this destination address that you need, and the data in your first packet that is sent, that data is just a request like, can I get the homepage of your website? So you're this packet and you're traveling around, and this kind of reminds me of that Dr. Seuss book, Are You My Mother? This little bird who's just been hatched goes around to all kinds of animals and asks if they are its mother. And that's not what an IP address or a packet is doing. Not since the invention of subnetting, at least, because we are subnetting things, that packet traveling around saying, do you know where this IP address is? Not are you this IP address, but what network is this thing in? And there's going to be plenty of edge routers that don't know at all. So the answer will be nope, and they will get the default route here. This is the network ID number for a default route. You'll understand more of this when we start looking at this pseudocode that routers are utilizing. This is basically the code that a router will run. It'll come in different forms, because those of you who have took my computer science class or my introduction to coding, you understand that there's like a million ways to create a program for the exact same purpose. All that'll come later. Just know that this packet that's traveling around in the internet, it is a smarter packet if it's asking for what network its destination IP is in. And we could be talking about a router as small as this thing. So here comes the packet in from the internet, and that makes this thing probably a modem/router. So once the packet's inside, this thing, router here, is going to go through its routing table and see if it knows what network the packet's on. Maybe the packet is on this network, so it'll send it down this pipeline. Or it's in another network, so it'll go through this yellow wire instead. But if it's not, then it's going to get that signal I was just talking about and go right back down, looking for other routers where it might know where its mother is or its destination IP address is. So to summarize so far, I've said that subnetting is improving the speed of things on the internet, because the packet can get a response faster if it figures out what network to go to first, rather than just checking with every single computer on every single network on the internet. So speed is going to improve. We're also conserving IP addresses, so we don't want the big guys, or we don't want little guys taking up big guy kind of ranges. So with subnetting, we don't have to talk about classes so much anymore. The networking guys will talk about class A, B, and C. Often they just mean, big networks, medium-sized ones, and small ones. Now, the other thing that subnetting is doing is it's organizing networks so we can provide better security and just control over these networks. And I'm curious, after I've explained that part to you, which of these benefits do you think is the most important of all? So let's look at a quick diagram, and we're not going to get really mathy in this lesson, but I want to show you via diagram of how things are working. So you have this packet. The box says IP datagram. That's pretty much the exact same thing as a packet. It's different terminology. So this packet comes and it has a destination address of 9.67.32.34. So once it arrives at this router, we're going to call it machine A. It says not, are you my mother? It doesn't look for this. It knows that this number isn't the number it is, right? 34 is not 17. So what this machine does is it takes the destination address, it ANDs it. You're using the logical operator known as AND. We've gone over that. You should know that before watching this video. So it ANDs that to come up with this network ID to check in its routing table to see if it knows where that destination is. And then in this scenario, that 9.67.32.32 is in its routing table, and it knows to send the packet to the gateway of 9.67.32.18. Because once there on that network, it should be able to find what it's looking for via .34. Now, if you didn't understand that too much, that's okay. We'll get more into that process later, and you'll practice that quite a bit later. But remember, you're the network administrator, so when you're looking at these diagrams, and this diagram is pretty extensive, right? You have your 255, 255, 255 here, all these ones, and then a couple zeros at the end. So like this is all written out because we're looking at this from that system administrator's perspective. Now, a lot of times when you're not doing that stuff by hand or trying to look at such a low level, you're just seeing the IP address and a slash with a number. This right here says everything that was in a large box like that, just in a condensed form. So let's say you're the owner of a small company, you're trying to create a couple networks for your employees to work on. And I don't know how many companies out there has the system administrator as the owner. But as you can tell, a system administrator is a pretty powerful person, right? They're in charge of all this complexity. So when you see this as a sysadmin, you can go ahead and in your mind understand that this is going to be a range from this to this. There's a lot of subnetting calculators out there for you to use, but when you're taking one of these certification tests like the Network Plus or a CCNA test, you'll be asked to do these calculations, and you're going to have to do them without access to like that subnetting calculator. But if you're just taking this class because you're interested in networking in general, well then that's okay. You won't have to hammer down the details like we will later. Just understanding how this works though should be pretty helpful. After all, one of the purposes of the subnetting idea was to save enough room on the internet, and in this day and age with IoT devices existing with their own IP addresses, we needed a solution like this. Though to give you a little spoiler here, that solution probably is through NAT, Network Address Translation, another concept I've done a video on. But subnetting is still helping make the internet a smaller, more manageable place. And if there's one sentence you remember about subnetting, this is the sentence, that the purpose of the subnet mask is to determine which hosts are on the local network and which are on the outside. If you see a single IP address, one without the slash at all, right? If you see just one IP, well then you're probably a router, not a human. You're a router. And you can take this number and use it against the subnet mask to see if it's in a number that's inside of you or somewhere you know of or not. And if not, you take that packet and move it on to its merry way somewhere else. So here's a great opportunity to answer that question, like what is the subnet mask doing? And just an FYI here for fun, if you do buy a range of IP addresses, maybe you want to start a company with a friend of yours, here's Aaron's fee schedule, and I was surprised at how low this price is right here. But then I read a little bit more and found out that you have to also pay an initial cost just to be a member of Aaron, just to have access to IP addresses or the ability to purchase IP addresses. And then once purchased, this number is an annual thing. So every year to keep those IP addresses, you gotta just keep paying, so your company better be making money in that case. So here's two great questions just to make sure you're sticking with me here. So networks, not hosts, not individual computers, networks are identified by a subnet mask, and everything beyond the subnet mask up to the 32nd bit is called those non-ones, those zeros, they're called address bits or host area bits. And what those are doing right there, okay, what those are doing, they're identifying each device or node on its network. So that's why you saw this table in the beginning of the lesson, because this table is allowing you to understand what portion of the IP address is the network portion. This is the frozen bits part. It's not changing on that particular network. It's staying the same. And then the rest of it is the host numbers. So we'll call these frozen bits here the leading bits. And whatever slash number there is, that is the number of bits that are frozen in place. Now you can look up your own IP address. You can type in my IP into Google and see what that is, or you can open the command line on Windows or Linux and you can type in something like ifconfig or ipconfig, depending on which of those systems you're on, and your computer will tell you what your IP address is and tell you what your subnet mask is, so then you could go ahead and figure out the name of your network. And then compare that to the individual name of the computer you're sitting at. So looking at this example of the IP address 66.94.224.0, what's the network portion? Well, this is actually one of the harder ones because it's not an even number. 19 doesn't give us an even break on the octets. So this first set is 8 bits. Here's another 8 bits, so we're up to 16. Now 19 is somewhere in here. So that gets tricky. And in your mind, you need to understand that this right here is called dotted decimal format. I'll take it easy on you here today and not do a lot of these, because they were one of the most difficult things for me to wrap my mind around when I was learning subnetting myself. So here we go. Let's try to keep it a little more simple. Here's an IP address and it says \8. So the question is, how many bits are in the network portion? Well, the first octet is just 8 bits, so that means this number 24, that's the name of this network. So 24 never changes, but 1, 2, and 3, these can be all types of different computers. Right now you might be feeling like it's this difficult type of riddle to solve, but there will be plenty of help for you. When you're doing this lesson in class, pause it and pop up your hand if you're getting really frustrated, and I can bust out the whiteboard and run through some of your questions. So let's look at one of those concepts in purely binary form now. So here's an IP address, so let's just, whatever that number is, that's the IP address, and here's the subnet mask. Now for the second IP address inside that network, this is a different number. See how that's a 0 and that's a 1, and over here it was flipped. So here's a brand new IP, but the subnet mask stays the same. And here's our third device, and same concept. This is a new number, but this is the same number. This will go on for a subnet mask like this. This concept will go on for 254 devices, where all these are ones, not just all ones and a 0 at the end. When all of these are ones, that concept is known as a broadcast. And if somebody is sending a message through broadcast on your network, it's trying to talk to all your computers at the exact same time. And one more thing, what's the slash on this particular example? You see we have 8 bits, 8, and then another 8. So this is 24 leading bits. That means it would be a /24 for this subnet mask. Down here I told you there's 254 devices. So if we go back up to our errand table, if I wanted a /24 network, so I have to pay this money to have the ability that includes 254 computers. That's just under $1 for every single computer to have its own IP on the internet. Now when you think about the bill you or your parents pay for internet each month, you can start mixing that information into how much of a profit they're making. Of course there's a lot more factors and variables, but that's going to be a little part of it, obviously. And here's another fun fact for you. I mean, this is like one of those apparentlys. I was doing all this research and I started seeing numbers written like this, 32 / and then 8. And I'm like, what is that? Where's all the other dots? Well, apparently some networking guys can look at a number like that and they understand that these are just zeros. So it's just not a big deal. Weird for me when I noticed that, and in class I'll go ahead and write out the zeros for you, but I just wanted you to have that information in case you're doing your own research and you see something like that. So I mentioned the concept of class before. That's how we used to organize the internet. If you owned a range of IP addresses on a class A network, then you're going to by default have a subnet mask that looked like this. But nowadays, again, we're not breaking the entire internet into just 3 chunks with these as an option only. We're able to use all kinds of other numbers to, again, efficiently organize the internet. Now, here's a good exercise. What happens if we did not subnet? Well, we would only be able to use one network from one of these classes, which is just unrealistic. Each data link on a network must have a unique network ID, and with every node on that link being a member of the same network. And don't get confused, this term data link, it's just the same as node, which is the same as host, which is the same as client. I am so sorry the guys who came up with this stuff decided to use so many synonyms. Maybe that's why people say when they hear two techies talking that it sounds like a whole nother language. Well, let's take a moment here to jot down the reasons we are subnetting. I've talked about optimizing performance, that is speed. The packet can hit several routers and ask if that's the right network versus hitting every single computer on its path. So subnetting is optimizing performance. Anytime you hear performance, they're usually referring to speed. Another thing it's doing is it's reducing network traffic. So think about it, if the packet can get to where it's going faster, that's kind of like a car. If the car can get to the place it's going faster, then that car is no longer just on the road. In this scenario with the internet, in this context, we're talking about the internet and electrical signals, so it's also going to have a reduction in energy costs. I know we're talking about super tiny voltages here, but the internet is massive, so it does add up pretty quickly. And then the third reason, the one I like to internalize the strongest, it is organizing networks, so they are manageable. The system administrator can control different networks depending on what they need to do. So anytime anybody comes up with a way to make my job easier, to make other people's jobs easier, that's awesome. That's giving us more time to do personal things and to have fun and to relax and do self-care and all this stuff. So I keep gravitating to option number 3 as like my favorite benefit of having a subnet. And speaking of self-care, think about it. You are told as a young adult that you'll need to keep your finances in more than one basket, right? Don't keep all your eggs in one basket. You'll need to approach life this way. So in case something like a catastrophe happens, you are prepared and you can move on. Well, somebody tweeted recently, I retweeted this. So if you follow me on Twitter, you'll see the same thing. It says that in a similar way, you can become more resilient as a person, more resilient to psychological losses if you diverse your sense of self-worth. So diversify your self-worth with your emphasis on the relationships you have, your own spirituality, the hobbies you choose, the career you choose or work towards, and the things you choose to do physically. Like all these things should make up your self-worth. You don't want to just put all your eggs in just one basket and that's all you focus on. Man, as a teacher, now professor who teaches young adults, this is something that they are severely lacking in knowledge of. So I feel good about teaching you all this networking stuff, but you need to keep these things in mind as well. So I made this a think right share right here because it's such an important idea. Maybe on your paper, if you're doing this on paper, if you're doing it on the computer, you have to find an up and down arrow. But I would draw an up arrow and say the more bits, okay, the more leading bits, those are the ones turned to a 1. The more of those you have, the smaller the range of IP addresses. So the larger the network number, the smaller the number of computers that can be on that network will be. So it's one of those inverse kind of relationships. So now we're about to go through some exercises to hammer this concept of leading bits into your head, and I'll give you a subnet mask written in that Cedar notation form, and all you have to do is tell me 2 things. Tell me what the frozen number is in the dotted decimal. Okay, so we're not going to do the binary right now. Not going to give you that headache. And then I want you to tell me how many leading bits there are. So if we were to do the binary, how many 1s would I be looking at? So buckle up. From here on out, we'll just practice reading a bunch of subnet notation. Then we'll finish this lesson with a reminder of the purpose behind subnetting, okay? So here's your number. What is the frozen number? And how many bits are you looking at? We'll do the first one together. Here's a resource if you were to need it, okay? But your answer for that question would be 192 is the frozen number, and there are 8 bits that are the leading bits, okay? All right, so time to take the training wheels off. Here's your next number. Pause here and do this one by yourself. And then I want you to pause on this one and try it out. Two more to go, so go ahead and pause here. All the answers will be at the end, so don't sweat it. And here's your very last one. Don't forget to pause and definitely give this a try. Because just writing down the answers, and here they are, that will do you no good. So make sure you pause and digest your process and digest what these right answers were, okay? So I hope you don't mind exercises like that. I mean, I wouldn't ask you to do them if they weren't helpful. And I also want you to approach these lessons with some creativity and like an open mind. When you have your own questions like this one, what is the largest cedar number you can have? That's a good one, and Google that and find out what the people are saying about that. And on the flip side, I was kind of thinking like, how large is the largest network out there? So though exercises and these three things may be things you hate, personally, the things I like to do is have these funky questions and go find the answers to those. So let me end on this, a challenge. This is one of those configurations that are not based on an even octet boundary. So if you can tell me what the network ID on this one is, I would be impressed. So that's the lesson. Remember, subnetting is all about being neat and tidy with our internet. It's about saying this network will have this many hosts, and then if you're a packet, you're going around and you're first going to find the network and then find the host. That's a smarter way to go about doing things. I did find an outside source if you're curious about what other people are saying are the benefits of subnetting. This is a pretty good article. The first one they say is to improve network performance and speed. So I mentioned that before. They say to reduce network congestion. So that's that traffic concept. Number 3 is boost network security. So that's probably my favorite, being a cybersecurity teacher. Everything I learned about computers is sort of for the sake of trying to improve safety so we can utilize these things to make a better world. The fourth benefit is to control network growth. And the fifth one the article will talk to you about is the ease of administration. So make sure you're using other sources outside of me to learn this stuff, especially if you could catch me making a mistake. That would be great. Let me know. I'll remake the video. And as a final creative Think Right Share, I want you to try to imagine a world without subnetting. Like, what does that look like to you? For me, I'm visualizing these giant circles, and there's only a few of them, and there's millions of computers on them, and this is really a bad idea because what if the entire circle goes down? So I'm kind of thinking of something like this. This seems like a bad idea to me. So I went out and found this picture, which really accurately describes the no subnetting world to me. And then this picture is a real one about the way the internet actually does look, which it looks like even more complex than the universe we live in. But after staring at something like this for a while, you can really see how that is representative of the internet. So if you were to be starving for more at this point, let me direct you to this link. If you're in my class, all these links will be posted on Canvas, so you could just click. But this link is going to teach you the same kind of thing, but in the context of working for Amazon. So if that's something you want to do, you want to work for the Amazon Web Services portion of that company, learning subnetting would probably be an important thing for you to learn.